In this video, I'm going to solve these three problems taken from the book Principles of Physics, 10th edition. The title of the chapter is Electric Fields. First question. A charged particle creates an electric field of magnitude 3 Newton per Coulomb at a point 0.8 meter away. What is the difference in the field magnitude between that point and one at 0.4 meter? So you have a charged particle. So better I will draw the diagram for this question. You have a charged particle. Let's we take the charged particle is this one. At a distance of 0.8 meter, what's the magnitude? Let's we take from the center to the distance. Let's we take this is R1. What is the R1 value? 0.8 meter. What is the magnitude of the electric field? E1, which is equal to 300 Newton per Coulomb. Now we have to find what is the difference in field of magnitude. So we are going to find what is the change in electric field. We are going to find the value of change in electric field. But how you can find the change in electrical field? First of all, we have to identify what should be the electric field at a distance 0.4 meters. So from here to here, let's we take this is our R2 and what's the value? And this is 0.4 meter, but we don't know what is the electrical field at this point. So once we identify the electrical field at a distance of 0.4 meter, we can easily find what is the change in electrical field, or we can find the difference. So the difference is nothing but the greater electrical field minus a smaller electrical field. Clear? So generally you have to see the diagram. Whenever the distance get increased, the electrical field get weaker. So if you see this picture, if you see this diagram, our electrical field at a distance of 0.4 meter should be greater than your electrical field at a distance 0.8 meter. So for this, we are going to use the formula of electrical field due to a point charge. So what is the formula? The electrical field due to a point charge is given by K Q over R square. So I'm going to use this formula for both cases. What are the both cases? E1 and R1, I'm going to use this formula. For E2 and R2, again, I'm going to use this formula. And after I identify the value of E2, we are going to find what should be the value for change in electric field. Or changing means the difference. So first I'm going to apply this rule for E1 and R1. Let's we take the electrical field 1, which is equal to K Q over R1 square. Likewise, I'm going to apply the same rule for this distance. Therefore, E2, which is equal to K Q over R2 square. Let's we take this is our first equation and this is our second equation. Now we have to identify what should be the value of E2. So what I'm going to do, I'm going to divide the equation 2 by equation 1. So if you divide, first of all, we have to divide the left hand side of the equation and then we have to divide the right hand side of the equation. So first I'm going to divide the left hand side, E2 over E1, which is equal to K Q over R2 square over K Q over R1 square. Now we have to rearrange this equation. If you rearrange, what you will get? E2 over E1, which is equal to KQ over R2 square multiplied by this R1 square will come to the numerator over KQ. So here the value of K multiplied by Q get cancelled. So what is remaining in the equation? E2 over E1, which is equal to R1 square over R2 square. Now our main aim to find the value of E2. So you have to again rearrange this equation in terms of electrical field 2. Therefore, E2, which is equal to, actually all these are vector. So here electrical vector quantity. So E2, which is equal to E1 multiplied by R1 square over R2 square. Now I'm going to substitute the value. The E1 value they mentioned as 300 Newton per coulomb, and R1 is 0.8 meter, and R2 value is 0.4 meter. We are going to find this value. So now I'm going to substitute these values in this equation. By that we will get the value of E2. That means electrical field 2 at a distance of 0.4 meter. So E1 300 multiplied by R1 square 0.8 square over 0.4 square gives the value of 300 multiplied by 0.8 square divided by 0.4 square. So we got the answer as 1200 Newton per coulomb. So this is the value of E2. But still, we did not complete the question because they are asking about the difference in electrical field magnitude. So we have to find what should be the difference value. So the difference value in electrical field, which is equal to the greater value of electrical field minus the smaller value of the electrical field, because here our second electrical field E2 has the greater value. So 1200 minus, what's the value here we have? We have the value of E1 is 300. So I'm going to substitute the value of E1 as 300. So the difference in electrical field, the difference in field, what field? Electrical field, which is equal to 900 Newton per coulomb. So this is the answer. Clear? So generally when the distance get increased, the field, the electric field get weaker. If the distance will be smaller, the electrical field will be stronger. That concept we used in this question. Clear? Okay. Read the second question carefully. And this question has some figure. So we have to read and we have to identify what is given in the figure. In the figure, the electrical field lines on the left side. So better I can draw the diagram again. So this is our diagram. Here all these arrow indicates the electrical field lines moving from right side to the left side. So better I can write here. This is our right side. This is our left side. So here in the left side we have a point B, and in the right side we have a point A. Now what is given in the question? The electrical field lines on the left have twice the separation of those on right. So you have to see the distance between the two lines. In the left hand side, the electrical field lines are double than the right hand side. This is the information. Clear? So if you want to frame the equation, we can frame it now itself. The electrical field lines at the place of A, which is equal to double the times of electrical field at the point B, because the separation here the 2 indicates it's double the separation. It's not double the times. So here EA is stronger, EB is weaker. Why it is weaker? Because whenever the lines gets more space, then the electrical field strength at the point will get weaker. So this is the information, this is the equations which they give in the first 3 lines. By using this, we are going to find 2 answers. So generally we are going to use these equations for the second question. So first we have to go finish our first part and then we can come and deal with this equation. So what is given in the first part? If the magnitude of the electrical field at A is 60 Newton per Coulomb. So what is the electrical field here? The electrical field strength at A point, which is 60 Newton per Coulomb. What is the magnitude of the force on the proton at A? So we studied these things in the theory. If you place the proton, positive charge here, the proton will be moving and the proton will have the force in the same direction of the electrical field. That means if you place the proton here, positive charge, it will experience the force in the direction of the electrical field. All these arrow marks indicates the electrical field direction. So if you place a proton, what will happen? It will experience the force in the same direction of the electrical field. So we are going to find what should be the force. Clear? So we already studied this information in the theory. The force experienced by the charge, which is equal to the charge multiplied by electrical field. Clear? Which field? The charge, the force experienced by the positive charge. Better I can put positive charge here. The force experienced by the positive charge, which is equal to the charge multiplied by electrical field strength. So which place we place the positive charge? We are placing the positive charge in the point A. So electrical field strength at point A. Now we are going to find the magnitude of the force. So I have to substitute the value. The charge value is 1.6 multiplied by 10 to the power of minus 90 multiplied by the electrical field strength at point A is given as 60 Newton per Coulomb. So here actually the electron is moving in the negative direction. So we have to get the answer in terms of negative. Why? Because it is moving towards the left direction. But in the question they just ask only the magnitude. So better I'm going to consider the magnitude of the value. So if you multiply, you will get the magnitude of the force experienced by the proton. So what's the answer? 1.6 multiplied by 10 to the power of minus 19 multiplied by 60, we got 9.6 multiplied by 10 to the power of minus 18 Newton. Actually the answer is negative. Why? Because the proton is moving towards the left direction, so we have to get negative, but we consider only the magnitude value. But I'm not mentioning this negative here. Actually the negative says the protons is moving in the negative direction. Clear? Okay, now we have to go for the second part. What is the magnitude at the point P? Magnitude of the electrical field at the point A is given as 60 Newton per Coulomb, but here we don't know what is the value at point B. For that, what I'm going to do, I'm going to use this equation, because these equations we framed after we read the first three lines from this question. Clear? So therefore, for the second part of the question, the electrical field at A, which is equal to double the times of lines separated in electrical field at point B. So I'm going to rearrange, because we are going to find the value of EB, that means the electrical field strength at point B. Therefore, EB, which is equal to the electrical field strength at point A divided by 2. As we already know, the value of electrical field strength at point A is 60. So 60 over 2 gives the answer of 30. So that means from the diagram itself, we will get the clear information, because it's weaker. Why it's weaker? You have to see the diagram. What is in the diagram? See the line. So if the space between the two lines will be greater, so electrical field strength at the point will get weaker. But in the right side, all the lines are very closely packed. So it's very close to each other. So the strength of the field at point A will be greater. Clear? So this is the answer for the B question. Okay. Third question. An electron is accelerated eastward at 3.4 multiplied by 10 to the power of 9 meter per second square by an electrical field. So first of all, I'm going to draw the direction. As we already know, this is the north, this one is south, this one is east, this one is west. So here, an electron, you are going to take an electron and you place this electron and the electron is traveling at an acceleration. What's the acceleration of the electron? The acceleration of the electron is 3.4 multiplied by 10 to the power of 9 meter per second. And here we have to find two answers, magnitude value of the field as well as the directions we have to find. So here if you just see the direction, when you place an electron in the electrical field, what will happen? The electrons will be moving to the opposite direction of the field. So here, which directions we have the electrical field? We have the electrical field in the direction of the east. Clear? Because what they mentioned, the electron is accelerated eastward by the electrical field. The electrical field is making the electron to moving in the eastward direction. So generally we studied in the theory, if you place the electron in the electrical field direction, the electron will move, the electron will experience the force in the opposite direction of the electrical field. Suppose if the electron, if you placed exactly in the same direction of the electrical field, it will have its acceleration will get weaker. Understand? So that is the concept, that is the theoretical information we studied in the theoretical part. Now we have to find what should be the magnitude. Why they ask magnitude? For sure its value should be negative, so we have to consider only the positive answer. And also we are going to find what should be the direction. So generally the electrons will move opposite to the direction of the electrical field. So the second answer, for the second question, the answer is the electron will be accelerating here. Why? Because it will experience the force only in the opposite to the electrical field. So first of all, we are going to find the electrical field magnitude. So for this, we are going to use the equation F, which is equal to Q multiplied by E. And we are going to find the value of the electrical field. Therefore, electrical field, which is equal to force over Q. Clear? And this is an electron, so I'm going to make negative. And what is the force? We have to experience the X, because the question is related with the acceleration. So we have to deal with Newton's second law, F, which is equal to ma. So in the place of F, I'm going to substitute the value of mass of the electron multiplied by acceleration of the electron. So E, which is equal to m multiplied by a over minus of q. So here minus q indicates the electron. Electron has the negative value. And we know the mass of the electron, it's a constant, which is 9.1 multiplied by 10 to the power of minus 31 kilogram. And the charge value is 1.6 multiplied by 10 to the power of minus 19. So now I'm going to substitute the value. So what should be the answer? 9.1 multiplied by 10 to the power of minus 31 multiplied by the acceleration of the electron here is 3.4 multiplied by 10 to the power of 9 divided by minus 1.6 multiplied by 10 to the power of minus 19. Now the answer should be negative. Why it is negative? Because the electron will experience the force in the opposite direction of the electrical field. So for that we will get the answer in terms of negative, but we are going to consider only the magnitude of the electric field. So 9.1 10 to the power of minus 31 multiplied by 3.4 multiplied by 10 to the power of 9 over minus 1.6 10 to the power of minus 19. So the answer I got is minus 0.0193, but we are going to consider only the electrical field magnitude, which is 0.0193 Newton per coulomb. This is the unit for electrical field. So this is the answer for the first part. What is the answer for the second part? We are going to find what should be the direction. So the direction, the electron will moving to the leftward direction. If the electron is accelerated by the electrical field in the eastward direction, the electron will be moving to the opposite direction. So the electron will be moving westward direction. Or you can mention in terms of x-axis also. If this is a positive x, this one is negative x. Or you can give the answer, the electron will moving in the negative x direction. Clear? So this is the answer. So for answering this question, you should be strong in the theory. Because when we studied the concept of electrical field, we studied the concept of positive charge. If you place positive charge in the electrical field, the positive charge will experience the force in the same direction of the electrical field. If you put the negative charge in the electrical field, it will experience the force opposite to the direction of the electrical field. So that concept we used in this question. Clear? That's it.